Okay, guys, welcome back. Welcome back to more graphing sinusoidal functions. So I said that today we were going to look at what happens if we have translations. So both horizontal, which we call phase shifts, or vertical, which have no special fancy name. So let's suppose our equation for a sinusoidal function will be in the form y equals a times either sine or cosine, right? This is true for both of them. Of b times x minus c plus d. So just as a recap, we already know what both a and b represent, right? Or how they affect the graph. We know that the absolute value of a is the amplitude of the function. And we know that 2 pi over the absolute value of b is the period of the function, right? Okay, so how do c and d affect the graph? So based on what we already know about transformations, we know that C represents the, I haven't used this color, C represents the horizontal translation, right? So C represents our horizontal translation, which we call, again in trig, a phase shift. Okay, so if C is positive, so if we had x minus C, we know we would shift the graph to the right. If we had x plus 12, we would shift the graph to the left. Okay, and then how about D? We know based on our rules about transformations that D represents a vertical shift. And there is no fancy name for that. I don't know why there is one for a horizontal shift with trig functions, but not vertical. Who knows? At any rate, one of the great mysteries of math, right? I'm sure you'll lose sleep over it. So D represents a vertical shift. If we are adding 2 to the graph, then it would shift the graph up 2 units. If we were subtracting 2, it would shift the graph down 2 units, okay? So this is really taking what we already know about the general shape of sine and cosine graphs and what we already know about horizontal and vertical translations and putting the two together to be able to graph any sine and cosine function. So one thing to keep in mind, which your brain may already be thinking, depending on what the period is and what that horizontal translation is, things could get really messy, right? Let's suppose your period is like, I don't know, pi over 3, and then you end up with a phase shift of pi over 5. Well, that's going to be really hard to do based on the way we've scaled our graphs, right? So my promise to you in our nice fake math world of making things pretty for you, I know you guys don't think it's pretty, but trust me, it is. I'm not going to make you shift anything that gets that messy, okay? So if your scale, let's say you're counting by pi over 4s, then it would be reasonable to me to shift maybe pi over 8, right? Because that would just be half a unit on the scale. Or to shift, pi over 2, because that would be 2 units. So, so just keep that in mind. If you end up with something that looks really, really funky that you're trying to shift, chances are something went wonky for you somewhere along the way, because I'm not going to try and do that to you, okay? Okay, so let's do an example or two. Let's suppose that we had y equals -3 times the sine of x plus pi over 2 minus 1. Yay. We'll put a little bit of everything in there. All right, so as we did earlier in the week, we're going to start with both the amplitude and period first, right? So let's talk about our amplitude and period, and then we'll talk about our phase shift and any vertical shift that we may have, and then we will graph. Okay, so our amplitude is 3. Just that absolute value of A, right? Again, the negative is going to be a reflection over the x-axis, but doesn't affect the amplitude itself. Our period will be, well, what's B? So B is typically the coefficient, right? Right here. Since we don't have anything there, that's just a 1, so the period hasn't changed, right? So the period is just 2 pi. All right, what is our phase shift? Well, we have shifted the graph. Since we're adding pi over 2, that would be to the left, pi over 2. And it's going to be really important that you keep track of instead of just saying left or right, I would write that pi over 2, and you're going to see why in a minute, why that's really important, okay? And then our vertical shift will be down 1 unit, okay? All right, so let's graph this. All right, so again, I'm going to start with my period, which is 2 pi. So this one I don't really have to think too hard about, right? So this will be pi over 2, pi, 3 pi over 2, and 2 pi. Again, we're labeling one full cycle on the x-axis, okay? All right, my amplitude is 3, but I know that I have to shift down 1, so I just want to make sure I have enough space here. Think about this ahead of time a little bit so it actually fits, okay? All right, so let's start with our original function. So our original sine function, and when I say original, I am including both this amplitude and period change, okay? So we've already marked off the correct period. Our amplitude is going to be 3. It's a sine function, so we have a point at the origin. Normally, we go up to the maximum, right? But don't forget that we had a negative coefficient, so we're going to actually go down back to the x-axis, up to the maximum, and back to the x-axis. So this is just y equals negative 3 times the sine of, x, yes. Okay? Now, all we're doing is taking that graph and applying both the phase shift and the vertical shift. So we are going to shift to the left pi over 2 units. And again, this is where you have to be careful. In this case, we're shifting pi over 2 units, which is just one space on our scale. But be careful that it may be something other than one space, okay? So just pay attention to that. Okay, so we're gonna shift 1 unit on our scale to the left, and then we're gonna shift down 1. And we can do that at the same time, right? Just like we always have. So we are going to shift 1 unit to the left and then down 1. 1 unit to the left and down 1, 1 unit to the left, down 1, 1 unit to the left, down 1. That's super fun. And then we will connect those so that my purple now is one cycle of my final graph. Again, if you need more than 1 cycle, then you would just continue that. Shoop, and you would keep going, right? And on in either direction. Okay? Simple as that. What's our domain? All real numbers, that hasn't changed. What's our range? Well, 2 things we've got to be careful of now, right? So our range is affected by our amplitude, we've already said, but it's also affected by our vertical shift, right? So now the smallest value on my graph is -4, and the largest value on my graph is +2. So my range then is from -4 to +2. That one's okay? Fantastic. All right, let's try another one. Let's do a cosine this time. And what do we want to do? Let's see. Let's try. Oh, that's a good one. Maybe not. Yeah, sure, I like this one. Oh, you guys will like this one. Okay, so let's suppose we have y equals 2 minus the cosine of x over 3 plus pi over 4. I know some of you are already going, oh gosh, just got all those fractions, things are all moved around. Okay, so let's start with this. Because this isn't exactly like what we have here, right? And sometimes people can get a little confused. This 2 here, is this the amplitude? It is not, right? Because the amplitude is what we're multiplying that trig function by. In this case, we're not multiplying it by anything other than a -1. This 2 is really which value? That's really my d value, right? So does it matter if I do this or if I just put the +2 at the end? Nope. So this is the same thing as just doing this, which I think a lot of people like better. For whatever reason in trig, a lot of times this is not written. And I have no good reason, right? What's the difference if we write -x plus 2 or 2 minus x? There isn't. But a lot of times, especially if it's a trig function, that 2 will come in front or whatever that constant is, especially if this is a negative coefficient here. Okay, so just something to keep in mind that that value is really our d value, okay? Okay, so now that we've established that, let's talk about amplitude, period, phase shift, and vertical shift. And then we'll graph. Okay, so let's start with the amplitude. Our amplitude is just 1, because the coefficient here is just -1, which is just going to be a reflection over the x-axis. Our period is, we've got to figure out what B is, right? So really, we need to rewrite this. What do we need to do? We can still identify B, right? But we're going to have to be careful with our, well, let's just do B. So B is this coefficient of x, right? Think about this. If I distribute this, then B times x, right? The B hasn't changed. So what's the coefficient of x is just 1/3, right? So my period is 2 pi divided by 1/3. So the period is 6 pi. Okay, now what's the phase shift? So our phase shift is, believe me, I'm like, I don't know what color to use. So many choices. Our phase shift, we have to be careful, right? Because remember that the phase shift is C, and that C value can only be identified if the coefficient of x is +1, just like it's always been. So we've got to factor that 1/3 out first. So this equation really becomes negative cosine of 1/3. This would be x plus what? Well, if we factor by 1/3, remember that we're really dividing when we factor that out, right? Dividing by 1/3 is the same as multiplying by 3. So that becomes 3 pi over 4. And again, you can always redistribute to check. Sometimes with those fractions, especially when we throw pi in there, it can get a little confusing. Okay, so now what's our phase shift then? Our phase shift is, first of all, is it right or left? Since we're adding, we know we're going to shift to the left, and that'll be to the left 3 pi over 4 units. Okay, and then it doesn't look at all like a 4, does it? And then our vertical shift will be up 2 units. Okay, so let's graph. Okay, so I'm just going to scale my y-axis by 1. Let's look at what our scale should be on the x-axis. So we're going to go out 1, 2, 3, 4, and that's going to be our period, which is 6 pi. Divide that in half, so this one's 3 pi. Divide that in half, so this one is 3 pi over 2. So what's this in between here? Indeed, it is 9 pi over 2. So you can either count 3 pi over 2, 6 pi over 2, 9 pi over 2, or average these two together, right? So 3 plus 6 is 9, and then divide by 2. Okay, so let's graph our cosine with the amplitude and period change. So we're graphing this cosine function, okay? Again, keep in mind that we also have that negative here. So cosine normally starts at the maximum, right, and goes down. Since it's a negative in front, we know that it's going to be reflected. So we're really going to start at the minimum, which is -1 in this case. We're going to go up to the x-axis, up to the maximum, down to the x-axis, and then back to the minimum. So in our period of 6 pi, our cosine function will look like this. Okay, now all we have to do is take it, shift it up 2, and to the left 3 pi over 4. All right, so again, here's where we've got to be careful. 3 pi over 4 is how much of our scale? Well, if we shift it over an entire unit, that's 3 pi over 2. Do we want to go 3 pi over 2? Nope, we only want 3 pi over 4, which is how much of 3 pi over 2? It's half of it. So we're really going to the left half a unit on our scale. So we're going to go to the left a half a unit and then up 1, 2. We're going to go to the left a half a unit and then up 1, 2. Go to the left a half a unit and up 1, 2. Left a half a unit and up 1, 2. I know you get the idea, but it's helpful if I keep saying it to myself over and over. Okay, so that is one full cycle of our final graph. And again, we could continue it infinitely in either direction if we wanted more than one cycle, okay? What is our domain? Our domain is all real numbers. And what is our range? So again, we're looking at both the amplitude and the vertical shift. So our amplitude doesn't change the range in this case, but we shifted it up to. So we're going to go from +1 as our minimum value to +3. Okay? Okay, so again, just keep in mind, you're identifying amplitude and period first and graphing like we did earlier in the week, and then just using that to do your final graph, applying any phase shifts and vertical shifts. Do you have to use transformations? I know somebody wants to ask that, and I'm going to give you the same answer I've given you all year. I think especially with trig functions, it's a whole lot easier to use transformations. It can get really messy to try and identify what the scale is if you don't use transformations, and it gets harder to plug in points too. If I look at this, right, keeping in mind that this is something you should be able to do without a calculator, right? If I have this graph here in front of me, or this equation, I'm sorry, and I'm going to try and figure out points to plug in. Imagine trying to find nice values. Okay, well, this is maybe a bad example because that's +pi/4, which isn't so bad. But at any rate, it does get messy to try and plug in values because there's a limited number of angles that you can evaluate, right? So it's, again, totally up to you, especially because I'm not there to even see what you're doing. But I think in the long run, it's going to be a whole lot easier for you to graph a trig function using transformations than it is to plug in points. Okay? So you've got some practice with this week. And as always, if you have questions, just let me know. Have fun graphing. I'll see you guys soon. Take care.